Hello friends, we are going to discuss decimal to binary conversion. If a decimal number is given, how to convert it as a binary number. For example, I am taking a decimal number 4. How to convert it into a equivalent binary number? So first you have to divide this number by 2. Why 2? Because the 2 is the base for a binary number. The binary number contains only 2 digits, that is 0 and 1. So that's why the base is 2. So here you have to write the quotient 2, the remainder 0, like this. If it is even number, when you divide it by 2, it always gives 0. When it is an odd number, it gives 1. When you divide it, you will take the whole number. For example, 5 divided by 2, the remainder is 1. The number you have to take 2 and you have to omit the 0.5. 5 by 2 is 2.5. So 0.5 you have to omit it, and 2 is the quotient and 1 is the remainder. You have to write like this. Now we have to divide continuously until it reaches the value 1. So here I am dividing 2 by 2. The quotient is 1. The remainder is 0. So now it reaches 1. So you have to take the values from the bottom to top. The bottom is the most significant bit and the top is the least significant bit. You have to write like this. So my input is 4. The equivalent binary number of the decimal 4 is 1, 0, 0. So what is my input? 4 is my input. 4 is a decimal number which is converted into binary 1, 0, 0. We will take another example and we will work out. Now I am taking a decimal number 50. 50. So I am dividing it by 2. The quotient is 25. Remainder is 0. Now I am dividing 25 by 2. So write the whole number 12. 25 by 2 is 12.5. So omit the fractional number. The remainder is 1. Again I am dividing 12 by 2. This is 6. The remainder is 0. Now I am dividing 6 by 2. Quotient is 3. The remainder is 0. Now I am dividing 3 by 2. 1.5. Omit 0.5. 1. The remainder is 0. When it reaches 1, we'll stop this division and take the values from bottom to top. The bottom is the most significant bit and towards the top, which is the least significant bit. So I will write 1, 0, 0, 0, this 1 and 0. So this is the binary equivalent of my decimal number 50. So this is the binary equivalent. So this is base 2 because which contain 0 and 1. So this is base 10 because it contains the value 0 to 9, 10 numbers. So this is the base. So in this video we have discussed how to convert a decimal number into its equivalent binary number. That's it. Thanks for watching this video. Please subscribe to my channel, share, comment and press the bell button. Thank you.